Hello everyone, I'm Binja. Welcome back to another video, and this is the second video for IGCSE Maths. Wait a second, CSE Maths 0580. In the last video, I had introduced you the types of numbers. We have natural numbers, integers, decimals, rational numbers, and so on. So in this video, we're gonna do the second most basic thing in both maths and add maths, which is sets. So this is kind of a I would say it's very simple, but it's not complicated either. So first thing, I'll introduce you the notation for universe, universal notation, and we represent it as an E. All right, if you want to go fancy, you can do something like this. So this universal notation represents every single thing in the whole set, right? So for example, from the first chapter, we say that the real numbers consist of every single thing. For example, Q, rational R, sorry, not R. Q is the rational number, and we have natural numbers, and we have integers. So real numbers consist of every single thing. So in a set, okay, in a set with a universal notation, this whole rectangle here represents R, the real numbers, right? And inside here we have Q rational numbers, then we go on to integers, then we have natural numbers, something like that. All right. So please make sure that this is correct, all right? Because I'm just giving an example. So yeah, this is the universal notation, which contains of every single thing. And the second thing we need to say is element. All right, this is a different one from the universal notation that you see earlier. So this represents element. All right. For example, if we draw something, okay, let's take back the example here. So we know that one is an integer, right? So we will say that 1 is an element of integer. So this is how we denote this element, all right? So it's written as this. And if it's not an element, so we will write with a slash, not an element. So for example, we will say that cert5 is not an element of rational numbers, all right? So this is how you denote is an element of and is not an element of. All right. So we will go on to the third notation, which is the empty set. All right. So let's say you are given. All right. So let's say this empty set means nothing is inside the set, so it's totally empty. All right. And let's go to the fourth one. Is we are gonna do numbers, number of elements. All right. So this end bracket means number of element of what. All right. So I'll give the example on the next canvas. All right, we are back here. Okay, so from here we say that the fourth thing here. Oh wait, okay, inking mode. All right, the fourth thing here we are talking about number of elements. So I'm gonna give a little bit of example here. This is the universal set, and this is A, and this is B. So let's say inside A here there's 5 elements, and inside B here there is 4 elements. So we will say that the number of elements in A is equals to 5. There are 5 items inside the set A. So this is the number of elements. So what is n bracket B? So it's equals to 4 because the number of elements inside B is 4 given from this diagram. All right. So after this, we will look at something called as the complementary. So let's say from the same example, from the same diagram here, A represents to this part. So this part is called A. All right. This part is called A. But if we have a little bit of stroke here, which we call this complement of A. So complement of A is everything except A. All right, so if I'm gonna draw this whole diagram here again, all right, if everything outside of A, it will represent like this, something like this. This means A complement. All right, so this is the few notations you will need to know, and we will go on to the next notation, which is subset. All right, number 6. This means a proper subset, and this means a subset. All right, what is the difference between subset and proper subset? So let's say A has the number 1, 2, 3, 4. All right, and B has the number 1, 2, 3. All right, so from here you can see that everything B has, A has, but A has 4, B does not have 4. So if we are to draw in this set diagram, oh my god, I'm sorry. If you are to draw in this set diagram, we will draw here it's A and here it's B. All right, because we have this 1, 2, 3, and 4 is here. All right, so the whole B is inside A. All right, so we call this a proper subset. So if you are given this information, we know that B is a proper subset of A. So this is how you denote. All right. So what about subset? Subset, if you can see, it's almost the same as proper subset, except there's a little underscore here. So this is actually meaning that if B now, okay, let's not take B, let's take C. Now C, it's given 1, 2, 3, and 4. So if in this diagram A and C is the same circle, because both A and C has the items 1, 2, 3, and 4. So when it's a subset, we will say that C is a subset of A, or A is a subset for C. It's the same because both of them are equal. All right. So subset, we usually use it as when there's equal one. If you want to use B is a subset of, oh wait, sorry, a subset. Yeah. If you want to say B is a subset of A, you can only write this when you don't know whether B is totally inside A or as equals as A. If you are given information like this, it's better that you use this one. Okay? So this is the difference between a subset and a proper subset. So we will next go to the complements of subset and proper subset. So it's basically uh what's the next one? Okay, the next one here. If this is means as a proper subset, then this means it's not a proper subset. All right, and it goes the same to subset and not a subset. All right, so this is the difference between both of them. And we will go to the last part uh of the notations for sets, and this is, wait a second, let me look at the number. We are at 6, so now at number 7, U and N. All right, so this is the most common notation you will see in the sets. U means union and N means intersect. Intersect. Oh, okay. and N means intersect. All right. So what's the difference between union and intersect? All right, I'm gonna draw this little diagram here again. This is the universal set E, universal, and this is set A and set B. All right. So if we are to say A union B, this means that everything of A plus everything of B. All right. So, or in word terms, we can say that it's A or B. So this, you will see why does this mean in the probability when you are learning in the higher higher boards. All right. So AUB, we will say A union B. This means everything here. All right. So everything is A union B. And if we are to say what is A, B, and if you are to say A union B complement, all right, you need to take note that if you see a little strike up here, it means everything except A union B. So it's everything outside here. All right. Okay. So next thing is the intersect one. Intersect. What is intersect? Intersect means it's A and B. All right, just give me some time here. A, B. All right. So when we are talking about A and B, it's talking about what A has and what B has. So it's referring to the one in the middle here. All right. So this is called A and B. All right. So the same thing is if we are to talk about the complements, second, if we are to talk about the complements here, A, B, if you have to talk about A intersect B complement, so it's everything outside here except the one in the middle. All right. So yeah, this basically shows every single thing from every single notation you will need to know for the chapter of sets. All right. So I'm gonna be doing a little bit of examples, and I'll clear this canvas here first. All right, so I took some time to draw these little two diagrams here. So I'm going to show you a little bit of example. What are the common things to be asked in the exams? So this is not likely to be asked, I guess, but you need to know some of this because these are the basics. Exams one are gonna be quite a little bit hard, which I'm gonna show later on. So please stay tuned, or you want to skip to the part if you wish to. So the first one here, we have A intersect with B prime. So this actually means A and everything except B. So first thing first, we know that we are gonna do it one by one. So we'll go with you can go with either A or B prime. So I will go with the B prime first. So first thing first, we know that B prime means everything outside of B. Okay, everything outside of B. This is B prime. So the second thing we're gonna look at is and A. So if we draw it with another thing here, we're gonna see the places where the both different directions of line intersect is this small part here. All right, is this little small part here. So this is A intersect with B prime. So this is how you actually look for the area that the question asks. And now we are going to go to the second one. This means B or everything except A. So what's the difference between this union and intersect questions here? So first we are going to do the same thing, B. So everything B, okay, or everything except A. So it's this one everything except A. So this is what it means. So what's the difference here is instead of taking the intersect between the area of intersection between the two directions of line, we are going to take everything where there's a line because it means or. So we are going to take either one. So either one should be included. So this is A, this is B. A prime union with B. Oh, by the way, prime means complement. You can call it anyways. Will be this area here. All right. This area here means and this included. Yeah, and this part is included too. All right. So this is A prime union B. So this is two little small examples on how the most fundamentals questions that that set can ask. So the next one I'm gonna talk about is how are you gonna draw a set? All right. Let's say for e.g., I'm gonna say that the number of elements of A is 5, and the number of elements of B is 6, and the number of elements of A and B is equals to 2. All right, and number of the universal is equals to 10. All right. So if you are given this information, how are you going to draw out? They ask you to draw a Venn diagram. So this is a Venn diagram. If I had not actually talked about it just now, this is called a Venn diagram because I just remember it, right? So this is a Venn diagram. You have A, you have B. So from the information given, how are you going to draw a Venn diagram? All right. And by the way, if you're drawing on in real life, you must make sure that this Venn diagram rectangle cannot have any spaces. All right. If not, it's wrong. So first thing first, we're gonna look at the smallest thing ever, which is this. The number of elements of A intersect B is 2. So we'll write 2 at here. All right. The reason why we don't write the number of elements of A is 5 here, because if you notice, A and B means A has the number of elements of 2, right? So this will make that the number of elements of A to be equals to 7 because 5 plus 2. So we don't do that, all right? So this is wrong. So how are you going to do it is you take from the intersect one first. You do the intersect first. It's equals to 2. And now you can start to solve A and B. So the number of elements of A is 5, which means 5 minus 2, so here is 3. All right, and it goes the same to the B part. All right, so if you are going to check here, the number of elements of A includes 3 plus 2, which is equals to 5, and for the number of elements of B is 4 plus 2, which is equals to 6, and that's correct. So from here, what is everything outside A union B? All right, the number of elements outside A union B. What is the number outside here? Because there is a possibility that something is outside here, right? So you are given that the number of elements in the universal is 10. All right, so every single thing inside this Venn diagram should be 10. So if we calculate A union B is equals to 3 plus 2 plus 4 plus 4, which is equals to 9, then you will know that number of elements of A union B prime is equals to 10 minus 9, which is 1, which means outside here is 1. So this is a very, very basic question, an example to do a sets question. All right, so I'm going to tell you something about listing down the elements. All right, if you notice that I had been just writing the elements inside here for, let's say this is A, B, I'll write this is 5, 4 and stuff. This means that the number of elements of A is 5. But what if the question wants you to list every single element inside the set? All right. For example, this is A, this is B, all right, A, B. For example, the question tells you that A has 1, 2, 3, and B has 3, 4, 5. All right. So if they want you to list what is inside set A and set B inside a Venn diagram, you cannot just write like this: 1, 2, 3, 4, 5. This is wrong. This is actually a wrong representation because this is referring to number of elements. So you can say the number of elements of A is 12 plus 3, which is 15, and that's totally wrong. So if you are to represent elements, you need to add a little dot in front of here, right? So dot 1, dot 2, dot 3, dot 4, and dot 5. So this is how you differentiate between number of elements, and listing the elements. So this is a very little small thing that you need to take note of. All right, so now we're gonna go to the last example of this video, and it's quite a little bit of complicated one, and we will end this video. All right. So at here, I have prepared an example. A survey collects response of a group of 100 students on sports they play. 28 plays soccer, 29 plays badminton, 19 plays cricket, and 14 plays both soccer and badminton, 12 plays both badminton and cricket, and 10 plays both soccer and cricket. 50 of them plays neither of the three sports. How many students play all three sports? So if you have seen this kind of long questions, don't be afraid. All right, we're going to do it one by one. So first thing here, we are going to be denoting them so that we can make our life easier. We will denote A as soccer, B as badminton, and C as crickets. All right. So from the information, we know that number of elements in A is 28. Number of elements in B is 29, and the number of elements in C is 19. All right. So from here, we know that a group of 100 students, which means the universal amount. Oh my God. I think I'll not do the fancy one, I'm just going to go with the easy one. All right. Number of universal elements is 100. This is something to take note of. All right. So now we have the number of elements of A and B is 14, and this can be known from this part. 14 plays both soccer and badminton, which means both soccer and badminton. So it's A and B. And if you list out all the others, number of elements in B and C is equals to 12. I press this again. And the number of elements in A and C is 10. And from here, you actually found out that 50 of them plays neither of the three sports. What does this mean? So it means that 50 elements, it's everything except A, B, and C. So if they play neither three sports, so we will write everything A union B union C, but they are outside of these three spots because they don't play any of them. So it's a prime is equals to 50. So what is the question? How many students play all three sports? Which means you are to look for number of elements of A intersect B intersect C. All right, so from here, you can solve using a lot of different ways. You have formulas and you have other one, but I will actually recommend you to use the set method to actually solve this kind of question because it's gonna make your life a lot more easier. So this is the universal set, the Venn diagram. This is A. Oh my God, wait a second. Okay, this is A. This is B, and this is C. All right, so this is A, B, and C. So it's the same thing as the example just now. We will start from the innermost part. All right. so that we can solve it. If you have learned algebra before, we would denote this as x. All right, so in the most middle part here, which is A intersect B intersect C, we will put this as x. All right, this is something that we still don't know and we are to find it out. So the second one here is the number of elements of A union B union C prime is 50. So we know that everything outside here is 50. Okay. So the next information we have here is A intersect B is 14. So this whole part is A intersect B, which means this little small part here means 14 minus x. All right. All right. Just take some time to understand why is it 14 minus x. It's because 14 minus x plus x is equals to 14. And this whole area here means A intersect B. Okay. And the next one we're going to look at is B intersect C, which is here. So here we're going to be doing, let's drag it up here because 12 minus C. All right. And last but not least, A intersect C is 10 minus X. Okay. So this is, we are doing slowly. All right. So we are finally at the outermost side. So number of elements of A is 28, right? If you just write 28 here, it's totally wrong because the number of elements of A according to this Venn diagram is 28 plus 14 minus x plus 10 minus x, because this whole thing is number of elements of A. So we cannot write 28 just like that. All right. So take note of this. Since we know that the number of elements of A is 28, we will write 28 minus this minus this minus this. All right, so it's this part. So from here, we know that the outside here, okay, let's drag it out here, is 28 minus 14 minus x minus x minus 10 minus x. If you write everything out, it will be something like this. So it will give you 4 plus x. All right, just take some time to actually see how does this work and why is it 4 plus x. All right, hope that I didn't do some wrong calculations. 14 4. All right, so it goes to the same thing for these other two parts here. So for B here, the number of elements of B is 29. So 29 minus 14 plus x minus 12 plus 14, which we will get 3 plus x. Okay. And last but not least, for the outside part of the C here, we have the number of elements of C equals to 19. So we will have 19 minus 10 plus x minus x minus 12 plus x, which is equals to x minus 3. All right. So after you have get every single thing here, you will now make use of the information of the universal amount. All right. So we know that from the beginning that the universal amount is equals to 100. So everything inside this Venn diagram here is equals to 100. All right. So we will list out every single thing we get here. Okay. So beginning from the outside one, which is 50 plus this part is 4 plus x. All right. So plus 4 plus x plus this one 3 plus x plus x minus 3. All right, so this is the outer part, and now we are going into plus 14 minus x plus 10 minus x plus 12 minus x, and finally the innermost part plus x. And this everything here is equals to 100. All right. So it's going to take a little bit of time. If you press the calculator, it's going to be faster. X 2 1 2 3. All right. And if we press the calculator here is 54 plus 3 minus 3 plus 14 plus 10 plus 12, which is equals to 90. All right, so it's 90 plus the x here is equals to 100. And here you solve that x is equals to 10, which means there are 10 students play all three sports. And this is how you solve a long, complicated question in your IGCSE exam about Venn diagrams and sets. So this is a little kind of a sample question that they will ask, but maybe it will be a little bit more tricky and maybe a different style. So it's similar to that, and yeah, you just need to take note of it. So yeah, this is all about sets. And thank you for watching this video. I hope this will help you. If you still have any confusion, please go to my Instagram and message me and any part that you don't understand or you need help, all right? And I'll be posting questions, a little bit of challenging questions there, or maybe not challenging for you, who knows, right? I'll be posting a little bit of challenging questions here. Oh, okay, my PC is in battery saving mode. Seems like I need to charge my laptop. So, all right, I'll see you guys next time. Thank you for watching.